The sun is a speck, a grain of sand in an endless desert. And somewhere out there floats a star so mind-bogglingly huge that you could fit 10 billion suns inside it and still have room to spare. You are about to meet the true king of the cosmos. Let's start with what you know. Our sun, that blazing ball of nuclear fire that keeps Earth alive, has a diameter of 1.39 million kilometers. It's so vast that 1.3 million Earths could fit inside it. Feels big, right? Now forget everything you know about size. Meet Stephenson 2-18. That is the current official record holder for the largest known star in the universe. It's a red supergiant located 19,570 light-years away in the constellation Scutum. And its scale will break your brain. Here's the number. Stephenson 2-18 has a radius estimated at 2,150 times that of our sun. Let me repeat that. 2,150 times the sun's radius. Not 20 times. Not 200 times. 2,150 times. If you replaced our sun with Stephenson 2-18, its surface would swallow the orbit of Saturn, Mercury, Venus, Earth, Mars, Jupiter, all vaporized. Saturn itself would orbit inside the star. Uranus and Neptune would be barely grazing its outer layers. The star's edge would stretch nearly to the orbit of Uranus, which is 2.9 billion kilometers from the sun. That's not a star. That's a cosmic abyss. But radius is just half the story. Let's talk volume. Volume scales with the cube of radius. That means Stephenson 2-18 could hold roughly 10 billion suns inside it. 10 billion of our local star. And since the sun can hold 1.3 million Earths, do the math. That star could swallow over 10 sextillion Earths. That's a 1 followed by 22 zeros. You cannot picture that number. No human can. Now let's make it visceral. Imagine you're in a spaceship flying along the equator of Stephenson 2-18. At the speed of a commercial jet, 900 kilometers per hour, it would take you over 900 years to go just halfway around. At the speed of light, you'd take 8.5 seconds to circle Earth. To circle Stephenson 2-18, light itself would need nearly 9 hours to travel around its circumference. Yes, you heard that right. Light, the fastest thing in existence, takes almost an entire workday to complete one lap around this star. That's how grotesquely huge it is. But here's where it gets even wilder. Stephenson 2-18 is not just big. It's dying. It's a red supergiant in its final evolutionary stage. It's already burned through its hydrogen, then its helium, and is now fusing heavier elements like carbon, neon, and oxygen in its core. That core is collapsing under its own immense gravity. And when that core runs out of fuel, which could happen in mere thousands of years, a blink in cosmic time, the star will go supernova. Not just any supernova. When a star this massive explodes, it will briefly outshine entire galaxies. For weeks, it will be one of the brightest objects in the universe. And then, it will leave behind either a black hole so massive that it would dwarf the one at the center of our Milky Way, or a neutron star so dense that a teaspoon of it would weigh billions of tons. But wait, is Stephenson 2-18 really the biggest? Science is never finished. For years, the title belonged to UY Scuti, with a radius of about 1,708 times the sun. Then came VY Canis Majoris at roughly 1,420 times. But improved measurements using the Very Large Telescope and Gaia spacecraft data showed that some of those earlier estimates were overblown because of dust clouds and measurement errors. Stephenson 2-18 survived the scrutiny. As of 2025, it remains the most massive in terms of physical size among known stars, though some candidates like WHG64 in the Large Magellanic Cloud give it competition. However, size isn't everything. Stephenson 2-18 is not the most massive star. That title likely belongs to our 136A1, a star in the Tarantula Nebula that has around 215 times the Sun's mass, but is only about 35 times its radius. Our 136A1 is compact, ferocious, and pumps out energy 8 million times brighter than the Sun. Stephenson 2 to 18, by contrast, is a puffed-up, bloated giant on its last legs. Think of a hot air balloon stretched to its breaking point. But that bloat is exactly what makes Stephenson 2 to 18 so terrifyingly beautiful. Its surface temperature is only around 3,200 Kelvin, much cooler than our Sun's 5,778 K. That's why it glows reddish. And if you stood on a hypothetical planet at a safe distance, the star would fill the entire sky from horizon to horizon, a silent red apocalypse. Here's the real mind-bender. Despite its insane size, Stephenson 2 to 18 is so far away, 19,570 light-years, that it appears as a faint, unremarkable point of light, even in powerful telescopes. It was discovered only in 1990 by American astronomer Charles Bruce Stephenson. For most of human history, nobody knew it existed. That's the universe's cruel joke. The largest thing we know of is barely visible. And there could be even larger ones. Our galaxy alone has an estimated 100 billion stars. The observable universe contains about 200 sextillion stars. Stephenson 2 to 18 is just the biggest we have found so far. There could be stars that stretch to the orbit of Neptune, or beyond. We simply haven't seen them yet because they're too faint or shrouded in dust. So the next time you look up at the night sky, remember that the tiny red dots you see might be cosmic monsters that could swallow our entire solar system without a burp. And we are living on a microscopic speck orbiting a mediocre star in a forgotten corner of one galaxy among trillions. If our sun were the size of a grain of sand, Stephenson 2 to 18 would be a mountain 12 kilometers wide. Now tell me, does that make you feel small, or does it make you desperate to know what else is out there?